So here's a quick rundown on some of the more popular RAID levels. It's not all of them. RAID 0 is called disk striping. That's just splitting the data across multiple disks. RAID 0 actually does not provide us any redundancy. I guess you can say it's zero RAID. Yeah, there is zero redundancy. Kind of a misnomer. It does increase speeds, but because it's splitting the data across multiple drives, you are actually decreasing your availability because it's now possible for one of 4 or 5 drives to fail and you still wouldn't have any of the data. Okay. Physically, the data is stored on the other disk, but the operating system's not going to know how to get it back. So RAID 0 is typically not used at all. RAID 1 is typically used for operating system drives on servers or high-end workstations where it is a simple duplicate. So what is written to disk 1 is written to disk 2. You have 2 drives that have exactly the same data on it. Disk mirroring in conjunction with something called disk duplexing actually separates the controllers to completely eliminate points of failure so that this server literally doesn't ever go down because of a hard drive error, unless we had one and we waited 3 months to fix it and we had another. So something would have to happen to both disks at the exact same time, which is possible, right? But we're talking about corruption and just a power failure or something like that. We don't want that to bring the server down. RAID 5 is disk striping and adding parity. So basically, RAID 5 uses multiple disks, at least 3, and on one of the disks, as it writes each bit, it writes a parity bit on one of the other disks. They're not all on the same disk. In this graphic, the orange are the parity bits. They're not all on the same. They are written there, though. And notice, let's go across the bottom because it's easy to follow. So disk 1 has a parity, okay, for disk E, which I guess is disk 5, right? Disk 2 has a spot for disk 1. You kind of go along and you see that they're split. The parity is spread across the multiple drives. So the failure of one drive, we can still retain data. We can stay up and running. You need all the other drives to make up the data that was on the one failed drive. Disk striping with double parity is just adding double parity. So, you can sustain more, possibly 2 drive failures, depending on the combination. RAID 1+0 is probably the most common. It's mirrored stripe sets. So it gets the high-speed advantage of a stripe set, but it utilizes mirroring in order to get the redundancy. You might be looking at this going, how many hard drives are we talking about? Well, that's the very reason we're talking about servers. And we may even be talking about something called a SAN, or a network attached storage. SANs are storage area networks. Network attached storage is a slightly different thing. Both provide storage that's accessible over the network, just in different ways. Both are generally divided up, include basically just a box full of hard drives, but then have software that you can use to configure how the drives are logically arranged, providing yourself with this redundancy. So RAID is a big deal. It's just more a big deal on servers.